Lesson 4 is on parallel and perpendicular lines. So parallel and perpendicular lines are kind of special when we're talking about graphing lines. We're going to be looking at a set of straight lines, so 2 straight lines at a time. Parallel and perpendicular lines appear all the time in the world around you. Think of streets, wallpaper, railway tracks, skyscrapers. Some cities, if you look at a map of the city, it's quite amazing how perfectly parallel the streets run and perpendicular the cross streets would run. This is just asking if you see any parallel and perpendicular lines around you. So I know I have hardwood floors, so I see lots of parallel lines there. Sometimes people have ceiling tiles and you'd see perpendicular and parallel lines there. So parallel lines are lines that run in the same direction and they never cross, and they would never meet. And I think when you're younger, probably your teacher talked about train tracks and how train tracks are parallel because the 2 sides of the track are never going to get closer together. They always have to be the exact same distance apart. Some symbols that you might see for parallel lines. So you might see a little set of arrows like that on parallel lines. And when you see those symbols, that's trying to tell you that, okay, yes, for sure, those lines are parallel. Or you might see there could be double arrows, or there could be even triple arrows. Perpendicular lines, that's different. Now these are going to meet at right angles, so they intersect at right angles. Perpendicular lines, you would often see a little symbol here in the corner, and that would be showing that this is a 90-degree corner. So that little square box in the corner is to let you know that for sure these 2 lines intersect at right angles to each other. So those are perpendicular lines. We can use graphing software to examine parallel and perpendicular lines. So if we just took just a second, I have Desmos open here. So if I type in a line like y equals 2x plus 1. There is a line, it's the y-intercept is 1, I go up 2 and over 1 and up 2 and over 1, and that has a slope of 2. If I add another line, y equals 2x minus 5. So now we have a different line, but these 2 equations have the same slope. They have the same m. They don't have to have the same y-intercept. In fact, when the y-intercepts are different, that's what makes the 2 lines parallel. So because these lines have the same slope, the incline of each line is the same. So hopefully that would make sense, right? If you have 2 equations of 2 lines and the slopes are the same, those lines should be parallel to each other. So we actually want our y-intercepts to be just something different. If this had the same y-intercept, then we're talking about the exact same line twice. So we don't want that. Those are not parallel lines. Those are just the same line, one on top of the other. We have to have different y-intercepts so that they are split apart. But the only thing about these 2 equations that make them parallel is the fact that the slopes are the same. These y-intercepts don't really matter as long as they're different. If we're going to talk about perpendicular lines, so lines that meet at 90 degrees to each other, can you guys imagine that this has a positive slope? So I know a perpendicular line that kind of makes an X with the red one. It has to have a negative slope because they have to meet at 90 degrees to each other. Let's say I did negative 2 minus 5. That's my equation. The slope is, instead of 2, it's negative 2. What do you think? Do these 2 lines look like they're perpendicular to each other? They're not quite right, right? This is not a 90-degree angle in there, and this angle's way bigger than 90 degrees. How are we going to make those 2 lines actually be perpendicular to each other? So like I said, instead of just having a positive number, let's make a negative number, but that wasn't quite enough. So here's what we're going to do. Instead of this 2 as our slope being 2 over 1, we're going to actually make our slope for our perpendicular line 1 over 2. So again, it doesn't matter at all what these y-intercepts are. They don't even have to be different in this case, because if this was a +1, that would be okay. They would still be perpendicular. So the y-intercepts in this case don't matter at all. The slope though, the slope is the big deal. The slope, if you have 2 for one of your slopes, 2 over 1, the other slope has to be negative, so they have to be opposite signs. And the 2 over 1 has to be flipped upside down. So that's called the reciprocal. Instead of 2 over 1, it's 1 over 2. So if we try a couple of different ones. So let's say we have y equals negative 2/3 x plus 4. Now, we don't have to have the same y-intercept to have a perpendicular line. No matter where the line crosses at 90 degrees, I could have a y-intercept way down here. I'm still going to have a perpendicular line if I have slopes that are opposites to each other. So by opposite, if this slope is negative, this slope has to be positive. So right away, it's not going to be negative now, it's going to be positive. They have to have opposite signs. And instead of 2 over 3, I'm going to have 3 over 2. So if I did plus 4, they look pretty much perpendicular to me, so 90 degrees to each other. 2 perpendicular lines. Look at the slopes, so negative 2/3 and positive 3 over 2. This is called the negative reciprocal. Opposite signs and then flip the fraction upside down. This plus 4 doesn't matter. This could be anything. So it could be plus 1. It's just this line is shifted lower. It could be minus 6. That is still a perpendicular line. It's the slope that matters, not the y-intercept. It could be negative 10. As long as the slopes are negative reciprocals to each other, you know you're going to have 2 perpendicular lines on a graph. So just again, if we had a slope of, let's just do y equals x plus 3. So there's a line. Now remember, the slope here is actually 1 over 1. This slope here is positive. If I want to come up with an equation for a perpendicular line, first of all, my slope has to be negative. If this one has a positive slope, this one has a negative slope. Plus 3 is the y-intercept, which doesn't really matter. The slope is 1 over 1. What happens if you flip 1 over 1 upside down? It's still 1 over 1, but now it's negative 1 over 1. So we could just write in y equals negative x minus 5. Y-intercept could be anything, but look at those lines. Those are perpendicular to each other. And I know this is I did this one on purpose because it's a little confusing. There is a slope in there. It's 1 over 1. When we flip it upside down, it's still there. It's 1 over 1, but it does become negative when the lines are perpendicular. The slopes of parallel lines then, in just conclusion there, they are the same. So if a line has a slope of 2/3 and another slope is 2/3 of a different line, those are parallel lines. The slope of perpendicular lines are negative reciprocals. So the equation of a line is y equals 3x minus 4. Give the slope, so just the slope of a parallel line. Well, a slope of a parallel line would also be 3 because there's our slope there. If it's 3, the slope of a parallel line is 3. The equation of a line is y equals 2/5 x minus 1. Give the slope of a perpendicular line, just the slope. The slope of this line is 2/5. The slope of a perpendicular line, this is a symbol we use for perpendicular. Slope of a perpendicular line would be negative 5 over 2. So this is positive, the new slope is negative, and we flip this upside down. That's the negative reciprocal. Example 2, write the negative reciprocal to each slope. So the perpendicular line would have a slope of negative 5 over 4. This, you have to remember 2 is the same thing as 2 over 1. So the perpendicular slope would be negative 1 over 2, upside down. The perpendicular slope for negative 1/3 is positive 3 over 1. But normally we don't write 3 over 1. We just write 3. Here, the perpendicular slope for negative 5, remember negative 5 is negative 5 over 1. The perpendicular slope has to be positive though, so it would just be 1/5. So example 3, are these lines parallel, perpendicular, or neither? So sometimes this is funny, like students will look at these two equations and they just try and guess. It's like, I don't know, there's some 3's in here. It looks kind of like they're going to be parallel. Well, what makes this a lot easier is to write these in y equals mx plus b form. It's really hard to tell what the slope is when your equation of your line is written in standard form. So even if it doesn't say, oh, you know what, to check that out, you should probably write these in slope y-intercept form. You have to know that this form, when I get my y alone, and I move my -15 and my x to the other side, you have to remember that this form is going to tell us what the slope is. It's going to be really obvious. So y equals -x/3, which would be -1x/3. 15 divided by 3 is 5. So there's my equation for the first one. The second one, if I isolate the y and I move the x term to the other side and the -1 to the other side, I see my slope here. So the question is, are those parallel? Are these two lines parallel? I have -1/3 for this slope and -3 for this one. So it's kind of close. If I had -1/3 and I had a perpendicular slope, it would be +3/1. So the fact that there's a negative here, these are not perpendicular, they're not the same, so they're not parallel, so these are neither. And again with this last one, when I first look at it, I see this slope here is 2/3. What is this slope? It's hard even for me to tell at first. I'd much rather write it in y equals mx plus b form. So I'm going to isolate the y and move the -6 to the right there, divide everything by -3. So y equals 2/3 x minus 2. So the y-intercepts don't matter at all. This one can be +5, this one can be -2, it doesn't matter. But I'm looking at my slope. This has a slope of 2/3, this has a slope of 2/3. These two lines have the same slope, so therefore the lines are parallel.